So, difference of perfect squares. Why do we call them difference of perfect squares? You might also see them called DOPS, which stands for difference of perfect squares. I had no idea why we called them difference of perfect squares when I first started studying this in high school. I only learnt this from a professor who came out and showed me this area model, and then it made perfect sense. So difference of perfect squares, you'll always find that there's a term, for example, x squared, and then it's going to be like, sorry, x, it could be x squared, and it's always going to be subtract. It has to be subtract. It can't be positive, and I'll tell you why. And let's go with 16. Now, I know that this, if I want to factorize it straight away, is going to be x minus 4 all squared. How? Because, well, x squared goes to x, 16, square root of that. Sorry, square root of x squared is x, square root of 16 is 4. Now, I said it needs to be negative, and I'll show you why. Let's just quickly go through this and expand this. This is technically x minus 4. You've got to look at it from, I suppose, what the expanded form is. And this is x minus 4, right? Now, when you multiply these, don't forget, and we will look at the area model, that's going to be x squared. That's going to be, whoops, yep, that's going to be, I stuffed this up. That's not x minus 4. This is x plus 4. That's how I'll factorize it, I should say. That's wrong. So that would be x squared. That would be plus 4x. Now, why it always needs to be negative is for this reason. You've got plus 4x's. Here in your expression, if I wrote this, right, I could also write this as x squared plus, I've got 0 x's, really, don't I? Like, they're not there. They've gone, right? Minus 16. So I need these x's to cancel each other out. To cancel out those x's, I need an expression, one to be positive and one to be negative. And when you'll notice, when I go x plus 4, that gives you 4x. Negative 4 plus times x is negative 4x. Negative 4x. Notice when you do the multiplication of x times 4, negative 4 times x, they cancel out the x's. Hence why I do the square root of 16, because this one, this positive number multiplied by x, and this x multiplied by this negative number, they need to cancel each other out because I need 0 x's, right? That's why it's the square root, because I need these to be the same numbers. So that has to be 4, and that has to be 4. Why this needs to be negative is because the positive of the 4x and the negative of the negative 4x, they need to cancel each other out. And the only way to do that is to have these terms as a positive and a negative. So a positive times a negative is always going to give you a negative answer. Hence, I said it always needs to be negative, right? So then you're going to get the last term, which is negative 4 times positive 4, is going to be negative 16. So that actually cancels each other out. Your x's are gone, right? And I mean, you can't do it. You can't cancel out the x's in any other way. Like if you've got, you know, x plus 4, which is a perfect square. Let's look at this one. That's where I got confused at the start. I mean, here, when you expand this, it's going to be like x squared. Then you're going to get plus 8x, right? You're going to have 2, you know, 4x plus 4x, and that's going to be positive 16. You can't, you know, this is a perfect square. This isn't a difference of 2 squares. Similarly, if it was 2 negatives, you're going to get, you know, x squared. That's going to be minus 4x, this one. That's also going to be another minus 4x. That gives you minus 8x, right? And then it's going to give you plus 16. So you can notice here you can't actually, you know, get rid of this. Like I don't have any x terms here. So you'll find that this number is usually squared numbered in level 8, level 9 where we are now. In level 10, we start dealing with things that aren't right. And it's just the square root of those, which is a bit easy, but we'll look at that another time. So that's the reason, okay? So we've got that, and that's how it gets to these factors. So I know that that's going to lead to x squared minus 16. Let's just look at this again. So we've got x squared minus, it has to be minus 16. It has to be minus because I've got plus 4 and minus 4. It will get rid of those x terms. Let's look at this as an array. So we know that this is going to factorize to minus 4, x plus 4, because that's going to get rid of my negative 4x plus 4x, okay? And it's going to also give me x squared and minus 16. If you think about this in terms of an array, and this makes sense of why do we call it DOPS? Why do we call it difference of perfect squares? Well, here, x by x is going to give you an x squared, right? This is going to give you 4x. These would be the same lengths, right? Because that's 4 and that's 4. This would give you minus 4x. And this would then give you negative 16, right? Now, if you think about this, this length is 4 by 4. This is a square, right? This is also a square because it's x by x. This is the same length. These aren't necessarily square because x could be 10, or 5. So it could be like 5 and 4, right? So, I mean, this could be like 4 by 5. It's not a square. So what you'll notice is that these two cancel each other out, right? These gone. Now, when you cancel each of those out, you're left with what in your array model? You're left with a square here, right? Which is my x square. And you're also left with the other square, of negative 16. Why do you think we call it difference of perfect squares? Well, you've got perfect squares. These are squares. Difference of perfect squares. Where's the difference? One is positive, one is negative. It's the difference between these two squares would be your answer. And that's why we call them difference of perfect squares. So what you'll find, why it needs to be exactly the same one, is because you've got to get rid of your x's. That's another way to look at difference of perfect squares. And that's how we can factorize difference of perfect squares. Let's look at a couple other scenarios. If you've got x squared minus 25, hopefully you're thinking, well, that's just going to be x minus 5, x plus 5. Why? That gives me x squared. That's going to give me negative 25. Negative 5x plus 5x gets rid of it. Leaves you just with that. So that would be your factored form. If you have to factorize this, it will be there because you've got no x's. Get no x's, that means this needs to be the same number. And one absolute number, absolutely, the absolute value needs to be the same, which means we ignore the negative and positive. One would have to be positive, one would have to be negative. So really, what are we doing? Really what we're doing, and let's go to level 10 now, is we're doing really the square root of that number, right? Which is 5. So really, if you've got like x squared minus whatever b is, you're just going to go x minus, or plus, it doesn't really matter, but one needs to be plus, one needs to be minus, square root of whatever the value of b is. How does this help? Well, let's just go with, I've got x squared minus 10. Oh, 10 I don't know the square root of. Like 8, like if it was 4, or if it was 9, or it was 16, it would be really easy. You can still do this. And that would be your answer. Whenever we're factorizing, the very first thing you're always going to do, you're always going to take out common factors. I just like using this because we're talking about DOPS. You always take out a common factor first. What do I mean by that? Oh, this is a tricky one to do, right? I mean, how am I going to get... This looks like it's a difference of perfect squares. If you're thinking about it, you're like, oh, 2. Well, if you tried to do this, the problem would be like, oh, well, 2 goes here, x, but then x would go here. But then that's not a perfect square because you've already made 2x a rectangle, right? Okay, so it's going to be the square root of 2x on the square root of 2x. Now you can do that, okay? And you could do the square root and square root, but we're not going to look at that. The first thing is easiest to do is always take out your common factors. Why? Because you're not going to run into this trouble. What's common in these? Is x common? No. Is there a numbers common? Yes, there's 2. If you take out 2, I'm left with x squared minus 4. Now that is a perfect square. That's going to be x minus 2, x plus 4, plus 2, sorry. Notice that this is multiplied by that. This is still multiplied by this thing. Like this would change into x squared. That would give you minus 2x. That would give you a positive 2x, which is 0x's, minus 4. So this is exactly the same as what is contained in these two brackets when you expand them. So you take out your common factor and then you can do it. Here, you can't do it. Take out your common factor of 3, though. There we go. That's going to be x minus 4, because I've got no x's. X plus 4. Easy. All right. So that's where you'll go. So one thing just to watch for is sometimes they may not look like a difference of perfect squares. But the very first thing you should always do before you factorize anything is always take out the common factor. That is number 1. You always do that. Every time when you look at an expression, go, is there something common between all the terms I can? If there is, whack it out the front and then just sort of ignore it almost and just deal with this. But always just include it because it's still multiplied. And when you expand it out, it still goes back to the same thing. So for example, if I multiply these two terms first, I'm going to get 3. I'm going to get x squared plus 4x minus 4x plus minus 16. No, that's 3. X squared, they cancel out. That's why we call it difference of perfect squares, minus 16. So we got back to the original one. Now if I expand that out, 3x squared minus 48. So you always take out your common factor first.